So the other general term that we will be encountering as we study bridge engineering is the word substructure. So what do we mean when we say substructure? So substructure is actually the term we use to describe all of the elements required to support the superstructure. Or in other words, these are the components or elements of a bridge that are located below the superstructure. These are the elements that are used to support the superstructure. So just like the superstructure, substructure also has its basic components. So these are the parts or elements of a bridge that comprise the substructure. So the first one is the abutments. Abutments are earth-retaining structures that support the superstructure at the beginning and end of a bridge. Like a retaining wall, the abutments resist the longitudinal forces of the earth underneath the overpass roadway. So abutments are actually almost the same as piers, but the only difference is piers are located on intermediate points between abutments, while abutments are located only at the beginning and at the end of a bridge. So those are the abutments. Again, abutments are those support of a bridge that are usually located at the beginning and at the end of a bridge, while the piers are the supporting structure or the supporting part of a substructure that are located in between abutments or in intermediate points between abutments. So usually abutments are used to retain earth because usually the beginning and the end of a bridge usually has earth to be retained so that our bridge will can have stability. So that part of the bridge, that part or component of a substructure that is usually located at the beginning and the end of a bridge, that is usually used to retain the earth beneath the beginning and the end of a bridge is what we call abutment. So they usually act like a retaining wall. So the longitudinal they retain the longitudinal force exerted by the earth underneath the overpass roadway. So the other component of a substructure is what we call the pier. So piers, just like abutments, piers are structures that support the superstructure at intermediate points between the end supports or the abutments. So this is what I am saying a while ago. Piers are actually almost the same as the abutments, but they are just usually placed in intermediate points or in between abutments. Abutments are usually placed at the beginning and the end of a bridge to retain earth, while piers are located in between these abutments. The physical conditions of the bridge site play an important role in deciding which type of pier to use. For example, to provide a large clearance makes a hammerhead attractive, while solid wall are well suited for shallow water crossings. So there are actually different types of pier, and this and deciding which type of pier to be used on a particular highway bridge site is actually dependent on the advantages of using that particular pier on that particular highway bridge site. So one example of a pier or pier type is actually this. This is what we call hammerhead pier. So this is the hammerhead pier. So hammerhead pier or hammerhead piers are usually used whenever we want to have a a large clearance underneath the superstructure. So you can usually see this type of pier on on locations like the 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 supporting pier a of our light rail transits here in the Philippines. So if you can notice, some of the piers used to support the superstructure of LRT, LRT1, LRT2 are actually hammerhead type pier. So why is that? Why do we use hammerhead type pier on those locations? So that we will still have a large clearance, a large space beneath the superstructure so that traffic can still flow beneath the superstructure. So that's one advantage of using a hammerhead pier. Another type of pier is what we call a solid wall or gravity pier. So this is what a solid wall or gravity pier looks like. So we usually use solid wall or gravity piers uh, whenever we have a bridge constructed on a shallow water crossing. So this type of pier are usually suited for bridges that are constructed on shallow water crossings. Another type of pier is what we call column bent pier. So these are the column bent pier. So it is just like you are having a very large column supporting the superstructure. So that is what we call the column bent pier. So the same as the hammerhead, the same as the advantage of using the hammerhead pier, we also use column bent pier so that we will still have a clearance, large clearance beneath the superstructure so that traffic can still flow along the direction of the bridge. So that we can still have a clear space here beneath the superstructure. That's why we usually use column bent pier. So we can if you already seen one column bent pier here in the Philippines, we usually use this for skyways. So we usually use column bent pier on skyway bridges, so that we will still have a clear space beneath the superstructure, so the traffic can still flow beneath the superstructure. Another component of a substructure are the bearings. So bearings are mechanical systems that transmit the vertical and horizontal loads of the superstructure to the substructure and accommodate movements between the superstructure and the substructure. Bearings allowing both rotation and longitudinal translation are called expansion bearings, and those that allow rotation only are called fixed bearings. So bearings look like this. So this is actually what we call bearing. Bearings are usually placed on the interface of the girder support or the primary member and the supporting substructure. So that is usually placed on their interface with the purpose of transmitting the vertical and horizontal loads from the superstructure to the supporting substructure. And another purpose of putting a bearing is to accommodate movements between the superstructure and the substructure so that there will be less stress that will be generated whenever there is a relative movement between the superstructure and the substructure. So that's why we are putting a bearing in between them so that whenever there is a relative movement between them, there is no additional stress that will be generated between the interface of the superstructure and the substructure. So bearings that allow both rotation and longitudinal translation are called expansion bearings, while those which allow rotation only are called fixed bearings. So another component of substructure is what we call pedestal. Pedestal is a short column on an abutment or pier under a bearing that directly supports a superstructure primary member. The term bridge seat is also used to refer to the top surface of the pedestal. So pedestal is actually just a short column on an abutment or pier under a bearing. So usually bearings are put above the pedestal, or in other words, pedestal supports the bearing. So the purpose of the pedestal is to, just like the bearing, the purpose of the pedestal is to actually distribute the load, or the loads that is being transferred from the superstructure to the substructure. So that's one purpose of the pedestal, to evenly distribute the load transfer, so that there will be less stress that will be produced on the interface of the substructure and the superstructure. Another component of a substructure is the stem. So stem is a primary component of the abutment above the footing, supporting pedestals. Its main function is to transfer loads from the superstructure to the foundation. So you can find stem on abutments. So again, take note, abutments are those pier-like part of the substructure that can only be found in the beginning and the end of a bridge. So you can find stem on that particular location. So stem usually supports pedestals. So its main function is again to, just like the pier and the abutment, its main function is to transfer loads from the superstructure to the supporting foundation. Another component of the substructure is the back wall. Back wall is the component of the abutment acting as a retaining structure on top of the stem. It also supports an approach slab if there is one. So later on, we will define what do we mean when we say approach slab. So, but at this point in time, let us focus on the back wall. So what do we mean? What is a back wall? So back wall is again a component of the substructure that can only be found on the abutment. So again, I'll repeat, abutment or abutments can be found only in the beginning and in the end of a bridge. So abutment are usually used to retain the earth uh, on the end, in the end, and in the beginning of a bridge. And in addition to that support, in addition to that abutment, usually we usually have also back wall or back walls, with the purpose the same as the abutment, which is to retain uh, retain to act as a retaining structure on top of the stem. So we usually place back wall on top of the stem. And another purpose of back wall is to support the approach lab. So when we say approach lab, although we will define it again later on, when we say approach lab, this is actually the very short slab that is used to connect the roadway and the bridge itself. So that very short slab is usually supported by the back wall. Another component of a substructure is what we call the wing wall. So wing wall actually looks something like this. So this is the wing wall. So if you can see here on the figure or the picture, the wing wall looks actually like a wing. So this is the triangular shape here. So wing wall is a side wall to the abutment back wall and stem designed to assist in confining earth behind the abutment. Wing walls may be designed parallel to the bridge and approaches, or they may have a skew angle, just like this. So the wing wall that we have here on this photo is actually constructed with a skew angle. So what is the purpose of a wing wall? The purpose of the wing wall is the same as the purpose of the back wall and the abutment, which is to retain the earth behind the abutment. So it is again an additional assistance, an additional support to retain the earth beneath or behind the abutment. So you can usually find wing walls on expressways. So if you had already traveled on expressways like NLEX or SLEX, you can find these wing walls on those part of the expressways where there is actually a bridge built over the expressway itself. So you can find those wing walls on expressways usually. Another component of a substructure which is actually a major part of the substructure, is what we call the footing or footings. So footings transfer loads from the substructure to the subsoil or piles. A footing supported by soil or bedrock without piles is called a spread footing. A footing supported by piles is known as a pile cap. Foundations supported by piles are also called deep foundations. So footings are one of the most important part of the substructure because simply because it is the part of the substructure, it is the component of the substructure that actually transfer the loads from the substructure itself to the supporting soil. Actually, when the footing is actually the one that transfers the loads from the substructure to the supporting subsoil, it is usually called a spread footing. If it is the one uh, who directly transfer the loads from the substructure to the supporting soil, it is called a spread footing or a shallow foundation. Although sometimes uh, the supporting soil has a very low or no, sometimes the supporting soil has a not so good quality, like it has a very low shear strength or bearing strength, or in other words, the soil is has a very low quality. Sometimes the supporting soil has a very low quality in resisting or supporting a structure. So sometimes a shallow foundation or a spread footing is not advantageous to use on that particular soil with low quality of strength, with low strength soil. So on those cases, we usually use uh, deep foundations, such as putting a pile. So a pile is the a pile or piles are used when the soil under a footing cannot provide adequate support for the substructure in terms of bearing capacity, overall stability, or settlement, which extend down from the footing to a stronger soil layer or to bedrock. There are a variety of types of piles ranging from concrete, which is cast in place, also called drilled shafts or caissons, or precast to steel edge section piles. Just like what I'm saying before, sometimes the supporting soil of a particular highway bridge site has a very low strength in terms of bearing strength or shear strength, or in other words, it has a very low quality. So on those cases, shallow foundations or spread footings are not advantageous to be used. So sometimes we are using what we call deep foundations, wherein we are using piles that are actually extended down uh, on the in the bottom of the earth until it reach a very strong soil layer or bedrock. So these piles are connected to the footing. So when the footing is actually used in the foundation, it is actually called pile cap. So that pile cap or simply footing that is used in the foundation is where the piles are inserted. So that the foundation looks something like this on the picture. So you can see here the footing or the pile cap and the pile. So the pile are simply looks like a very long column that is embedded deep beneath the earth. It is actually extended deep beneath the earth until it reaches a very strong soil layer or bedrock, and wherein it can transfer the load or the loads that is or that are being carried by the substructure. So we usually use piles, the foundations, on soil site. I mean on highway bridge sites that have a not so good quality of soil. So we usually use those the foundations on those highway bridge sites that have a not so good quality of soil. So in which case, shallow foundations or spread footings are not advantageous to be used. So those are the uh, piles. That is what a pile looks like. And then again, that part of the foundation, that's that rectangular part, is again what we call the footing or the pile cap. So again, we usually call footing a pile cap whenever we use it in deep foundations, whenever we insert a pile on it. So the last component of substructure that we will study is the the word or the term sheeting. So what do we mean? What is this component of a substructure, which is the sheeting? What do we mean of sheeting? Sheeting is the vertical planks that are driven into the ground to act as a temporary retaining walls, permitting excavation in coffer dams or shallow excavation. So what does a sheeting looks like? So sheeting looks like this. So this is what we call sheeting. So sheeting are actually just composed of vertical planks, several vertical planks that are interweaved together to form an enclosed space. So usually in actual construction, in order for us to provide a temporary retaining wall, especially on construction projects that are located on bodies of water, we usually uh, conduct what we call sheeting, wherein we insert a vertical plank, several series of vertical planks uh, deep beneath the earth, beneath the water surface, and then until we have an enclosed space. We insert series of vertical planks beneath the earth, beneath the water surface, until we have an enclosed surface like this one. So, until then, uh, when we already have an enclosed space like this one, what we do is excavation of the earth beneath the water surface can already be started, as well as the drainage of the water inside the enclosed space made by the sheeting. So this is how we usually construct the foundations of bridges that are located on bodies of water. We usually insert their sheeting, which acts as a temporary retaining wall. Usually insert it or insert them deep beneath the earth to form an enclosed space. So when we already have a or an enclosed space, what we do is we excavate the earth enclosed by that sheeting together with the water that is also enclosed on that enclosed space formed by the sheeting. So in that way, we can already start excavation and the foundation works. We can already start or commence the foundation works for the support or the substructure of a particular bridge that is located usually on a body of water. So that is sheeting. Actually, this construction or activity or operation that you are saying here is what we call coffer dam. This is what coffer dams should look like. So coffer dams are actually this enclosed space that are usually used for foundation works on bodies of water. So you can also find sheeting sometimes on the sides of a river. So one another purpose of these sheetings is to retain uh, is to act as a retaining wall. That's why we usually also use this on the sides of a river so that we can retain the soil on the side of the river. So on the side of the river so that these soils will be retained, this earth will be retained and will prevent erosion on the river. So those are some of the basic components of a substructure. So those are the terms that we will encounter later on as we study bridge engineering.